Welcome dear students. In the previous lecture we discussed what are significant figures and what are the rules to decide the number of significant figures in a value. Now this lecture is about the addition, subtraction, multiplication and division of the significant figures. First of all we will discuss the addition and subtraction. My dear students, these are two cases in front of you in which you want to add these three numbers, and in the second case you want to add these three numbers. First of all, you will write down those numbers that you want to add, and then simply you will add those numbers just according to the normal mathematical function. So I have written these three numbers, and again I have written these three numbers in case 2. Now I will add them simply according to the simple mathematical rules. Here will be 2, 1 plus 1, this will be 2, 1 plus 0 plus 0, it will be 1, point 2 plus 8, 10, 10 plus 1, 11, 1. So there will be factor 1 here, and you will add, it will be 31. So the answer will be 31.122. Now after adding the numbers in a simple manner, now you will decide the limiting term among the values that you have added. This is the key point to the addition. Now listen very carefully, that you will have to decide which of the following is the limiting term of the values that you have added. Now the limiting terms in case of addition and subtraction is the one which has least decimal places. Look at these three values. This value has 2 decimal places, this value has only 1 decimal place, and this value has 3 decimal places. So limiting term is the one with the least decimal places. It means out of these values, this one is the limiting term with the least decimal places. Now the rule is that answer should have same number of decimal places as present in the limiting term. If the limiting term has 1 decimal place, then the answer should have only 1 decimal place. So you will round off this answer to this one, and answer will be 31.1. This one will remain unaffected as the number next to it, that is smaller than 5, and you are well aware of the rules of the rounding off, that if the number will be smaller than 5, then the next number will remain same. So the answer will be 31.1. Now let us discuss this second case. First of all, we have written down the values that we want to add, and now we will perform simple addition. 9 plus 4, 14, 3 plus 7, 10, and 1, 11. 4 plus 3, 7, 7 plus 7, 14, and 1, 15, 5. 2 plus 9, 11, 11 plus 5, 16, and 1, 17, 7, and it will be 3. So answer will be 37.514. Now again decide the limiting term among these three terms. This one is having 3 decimal places, again 3 decimal places, and it has only 1 decimal place. So the limiting term is the one with the least decimal places. It means this will be the limiting term. And your answer should have same decimal places as those are in the limiting term. So this answer should have only 1 decimal place, and you will round off this answer to 37.5. As the number next to this 5, this one is 1, it is smaller than 5. So again there will be no effect on this 5, and answer will be 37.5. The same rule is for the subtraction. I have given a case. Suppose we want to subtract these two numbers, the answer will be 107.37. You will have to simply perform the subtraction function. Now this answer 107.37, it should have same decimal places as present in the limiting term. Now out of these two, the limiting term is this one, as it has only 1 decimal place, but this value has 2 decimal places. Limiting term is the one having minimum decimal places. It one is the limiting term, and the answer should have only 1 decimal place just equal to the limiting term. So the answer should be 107.3. But as this number 7 is larger than 5, so while rounding off you will add 1 in the number next to it. So answer should be 107.4. That will be the answer. So the gist of this discussion is that during addition and subtraction you have to decide the limiting term and then the answer should have same decimal places as present in the limiting term. Now let us move towards the multiplication and division. In case of multiplication and division, first of all, you will write down the numbers that you want to multiply or divide, just like I have written here, and then you will simply perform the mathematical function of the multiplication and division. When you will multiply these two numbers, the answer will be 3.125. Now, during multiplication and division, which will be the limiting term? The concept of limiting term in multiplication and division is different from that in the addition and subtraction. Here the limiting term will be the one with minimum significant figures. So you must have an idea how to calculate or how to find the number of significant figures in a value. This value has two significant figures because both are non-zero numbers. This value has three significant figures. Now the limiting term is the one with minimum significant figures, and this one will be the limiting term. So the answer should have same number of significant figures as present in the limiting term. The answer must have only two significant figures. So you will round off it to the two significant figures. Answer will be 3.1. These two numbers, they will not be represented in the answer because the answer should have same significant figures as present in the limiting term. Again, this 2, that is smaller than 5, so there will be no effect on this one. The answer will be 3.1. Now let us divide these two numbers. When you will divide these two numbers, the answer will be 534.78261. Again, decide the limiting term out of these two. How many significant figures are present in this? 1, 2, 3. These are the trailing zeros, so they are also significant. 1, 2, 3, 4, 5. It is having 5 significant figures. And this one, because these two are the, in the lecture of the significant figures, we have discussed that these are the leading zeros, the zeros preceding to the first non-zero number. So they will be insignificant. There will be only 3 significant figures here. So the limiting term is this one with the minimum significant figures, and the answer should also have the same significant figures as present in the limiting term. So your answer will be rounded off to this 534. Now it will be 5,3. This 4 will be increased to 1 as this number is larger than 5. So it will be 5350000. This will be the answer. If you want to write it down in the scientific notation form, then you will have to jump this 0 to this point and it will become 5.35, and the decimal has jumped 1, 2, 3, 4, 5, 6, 7, so it will be 10 raised to power 7. Now dear students, according to the rules of the significant figure, the exponential form is not considered as significant, so it will having only 3 significant figures, and the answer will be 5.35 into 10 raised to power 7. The limiting term has 3 significant figures. In the same way, this answer will also be having the 3 significant figures. So this was addition, subtraction, multiplication and division. Now let us discuss shortly what are the rounding rules for significant figures. My dear students, if you want to round off these numbers, I have written different cases of these numbers. Listen very carefully. This number can be rounded off to 6.63. We want to round off all these numbers to 3 significant figures. So it will be 6.63. This one will be increased by 1. This 2 will be increased by 1 factor because this 6 is greater than 5. Similarly, this number will remain 6.62. Why this 2 is not increased? Because the next number is smaller than 5. And if the number is equal to 5, then here the number was greater than 5, so you added 1 in the next figure or in the next digit. If the number is smaller than 5, the next one remains unchanged. If it is equal to 5, then there are 2 cases. If the number is equal to 5 and the next number to it is even number, then it will remain unchanged. Answer will be 6.62. But if here is 5 and the number next to it is an odd number, then it will be increased by 1 and it will be made even. So here the answer will be 6.64. I have discussed the case in which you wanted to round these figures to three significant figures. If the number is greater than 5, you will add 1 to the next. If it is smaller than 5, the next will remain unchanged. If it is 5, then you will see that the number next to it, it is even or odd. If it is even, it will remain unchanged. If it is odd, then you will add 1 to that number and make it even. Similarly, if you want to round off this value to three significant figures or two significant figures, what will you do? Suppose we want to round it off to two significant figures. First of all, you will move this decimal to this point and you will write it down from standard notation to scientific notation. It will become 7.36 into 10 raised to power. As you have moved it towards the right, so answer will be minus 1, 2, 3, 4, it will be minus 4. These zeros are insignificant zeros as they are the leading zeros preceding to the first non-zero number. Now this one is the exponential form. This 10 is for minus 4 is insignificant according to the rule of the significant figures, and if you want to round it off to three significant figures, then the answer will remain 7.36. But if you want to round it off to two significant figures, then it will become 7.4 into 10 is per minus 4. These will be the only two significant figure. Why this 3 has become 4? Because the number next to it that was larger than 5. And if you want to round this case 1629 to two significant figures, how can you round it off to two significant figures? I am leaving this question to you as a challenge case, as a test case, and you will answer it in the comment section. I will check the answer and I will tell you which one is the correct and which one is the incorrect. So this is a practice question for you people. You will solve it and you will write the answer in the comment section. This was all about the addition, subtraction, division and multiplication and rounding of the significant figures. If you feel any problem, feel free to ask in the comment section. I will definitely answer them. Till then, take care.